To show linked data at work, we will need to set up a scenario with a few services first. Imagine a service, an API provided by the company's house, that returns a list of existing registered companies with their name and number. A team at the Department for International Trade is tasked to build a service that deals with companies exporting from the UK. Although they know about the company's house service, that model is not suitable, so they will make their own. Another team at DIT builds independently a service for importers with their own data model. It is just a made-up example, so we will need some smoke and a few mirrors to make it look real. And here it is, data from our made-up services. So here is our scenario from a different perspective. We have 3 services built by 3 teams at 2 organizations. Although all the services deal with British companies, they model them differently to meet their service objectives. A 4th team is created and tasked with building a new service, a service that will use data from the other 3. It will display a combined list of importers and exporters with their registered company number. They start by reading the documentation of existing services and mapping their data to their own. It is our team, so let's make it happen. Firstly, let's connect to the exporters service and get the data into the exporters variable. It comes in the original data model, so we need to convert it to our own. We want name to come from the name, but the exports variable will come from exported products. With the exporters done, let's do the same for the importers. The difference here is that the name comes from the importer property. And so we are ready to combine exporters and importers into a single list called companies. It sort of works, but we appear to have duplicates. It turns out that not only the models were not aligned, but also the data itself. We now need to understand the differences and create the mapping in our service. Now we will follow the same steps to bring the data from the company's house API. You have seen it before, so you'll fast forward until the point where I realize that one company is still not mapped. It isn't exactly a surprise. It is a very common problem in this approach to working with data. We can easily fix it. Finally, a touch of data cleanup, and we've got a nice list of all companies, both importers and exporters. Let's have a look at what we have accomplished from the system's perspective. We have created strong dependencies. Any change to the 3 original services has a potential of breaking our new service. It could be fine, as long as the other teams don't change anything, or at least if they let us know. There is, obviously, a well-established alternative solution. We already know all the 4 models. We will get all the teams together, form the necessary bodies, and lead a multi-year project that will deliver a single data model with merged data of the highest quality. We no longer depend on the other services, but they all depend on our shared model. Either solution is fragile, as it requires a lot of coordination between the teams. So let's go back a few steps and see how we could collaborate with linked data instead of coordination. Let's start with the exporters service. The team maintaining it, without talking to anybody, decides to publish JSON LD description of the model. There, they declare what an exporter company is and what individual properties mean using standard external vocabularies like schema.org. They make the definition available on schema.gov.uk and decorate the data returned by their service with @context attribute. This is to let everybody know what data they return and what it means. We can now build the new service in a different way. We will still connect to the exporter service, but instead of working directly with the data model, we start constructing a graph of knowledge. To list company names, we will ask for it using a standard schema.org vocabulary term, name. We now have the exporter's names. Now, when we connect to the importer's service in the same way, nothing happens. That is because the importer's teams haven't heard about the linked data yet. We explained to them the benefits of it, and they published their context too. We don't have to make any more changes to our code. We are already connected, and so the data becomes available to us. As we keep talking about linked data, the company's house teams decide to join as well. It appears to be working, but we still have a problem with data quality. To understand why, let's look inside the graph to see what's happening there. First of all, it appears that the company's house data is missing from the graph. But also, the names come from both exporters and importers service. The company's house data is missing because the API does not notify us about the context. That's easy to fix. However, the names problem just became more difficult. Now we have possible free values to deal with. We could have asked the company's house to change their model, but the whole point is that we can collaborate without coordination. So instead, after getting the graph from their service, we will update it and copy the name property into the primary name. It's only ours, only we are changing and nobody else has to know about it. Let's query the primary name from the graph, and now we have a list of canonical names of exporters and importers. We can now use similar techniques to add company number, the number of imports and exports. Our futuristic new service is working as expected. But let's see what happened to the old one. Despite changes to the APIs, it still works. But what would happen if the importers team decided to rename their property? The old implementation breaks, but the new one still works. Okay, so we were able to survive a schema change. But what if the same team decided to use a different vocabulary term? It's not just a company number, they want to say it's the official company number. Even the linked data service is broken now. But yet again, we can fix it without talking to anybody. We can use the web ontology language, OL, and define that those terms, the old and the new, are synonymous for us. With a small change to the SPARQL query, we will use the synonyms, and it works again. So what have we done this time? Instead of building dependencies, each service publishes their description. Of course, those are dependent on things, on common vocabularies, but the point is that the services do not depend on each other. The new service depends only on those descriptors, and not the services.